Let's get it going, everybody. What's going on? Little quick word of warm up. I'm on a little bit later than I thought, but we got the workout done. We got breakfast made. We got a couple chores done. So that means we can focus here for a solid 2-hour chunk. Everything structural engineering, wood design, study related for the SE exam. So I always feel like I know wood pretty well. So for me, this should hopefully be pretty quick. So let's just go over what we know, what we need to know, where to find that information based on the computer-based testing format that we have to do now, and let's shake off this material and move on to the next. Concrete. So, hey, welcome in. Hopefully your Sunday or whatever day it happens to be for you, if it's like the next day in the future in Japan or something, I don't know, is going really well. And whatever you're studying is starting to click for you, and you're, excelling at it. So let me know what you're up to, what you're studying, where you're coming in from into the auditorium, and let's warm up with some Wordle, and let's get into it. See you, everybody. I said see you like I should leave here, but no wrong answers. Only learning opportunities. And I had a grate Tim doing it. It would have been too easy. That would have been phenomenal. We go 2 guesses, but we do have a lot of info. Hang on. Oh, no A. Okay. Nope. Egress, I think, has 2 S's, right? Yeah. Okay. What happened to the tunes? But me lowered the tunes. Hang on, stand by. Alright, we can roll with this. Ooh, what about like a... it's kind of a waste of a guess, but I'm gonna go for it. Okay. Some good info. So no E, so E's at the end. All right. And we have an I. Let's see. I blank G E. Oh, I can't go there. What am I doing? Oh, so we know I has to go here. Oh. I'm just going to do it U just for the placeholder. I mean, does that even work? Oh, come on now. Come on now. Okay, it's a 4. It's a solid day. It's not exponential. I wanted that 3, but it's all right. All right. Let's switch to our lo-fi beats. Something to throw on in the background. Bada boom. Mar, welcome in. Karthik, welcome in. That's a, if I said that right, it's a sick name. All the way from Cincinnati. Welcome in. You guys just get hit with a snowstorm, I believe. Talking with a couple of my friends back east. And I thought I heard some snow rolling through. Hey, welcome in. I think what I'm gonna do first, I'm looking at my notes that I took for wood last go around, so they're all paper based in front of me here. Yeah, 2 inches, let's go. I love me some snow, some fresh snow. It always gets me in the right state of mind to get some work done. I don't know why, I've always liked it. And let's do some, I mean, let me think here. Like, we got shear walls, solid and perforated. And force transfer around opening. And so that's our shear walls in plane. You got out of plane analysis, which isn't really that, I mean, it's just a stud bending. It's not very that difficult. You got some sheathing that tables for out of plane as well. Your diaphragms are really straightforward. You design them just like you design your shear walls. Not a big deal. You know, you got your cords. You got collectors. And I think really the biggest standalone thing for wood design that stands apart from other materials is like sub-diaphragm analysis. So we'll be making sure to look into that as well. But yeah, let's start with a couple of shear walls. That's what I'm gonna be working on. Hey. Eduardo, thanks for subscribing. And hey, remember, boom, bada boom. We got a little tracker, something fun, something to engage with a little bit. If you are not subscribed to the channel and you do want to be, if you're an engineer, specifically if you're a structural engineer, but you don't have to be, consider subscribing. That way you're alerted with all of the content that I'm creating when I go live, stuff like that. Or you can turn off all the notifications and I not bother you. But you do get to reserve your seat in the auditorium. You get your nice, red cushiony chair. You get your pick of anywhere besides the other seats. But yeah, consider it. You don't have to though. Don't sweat it. Dennis, welcome in. I did not pass the lateral, so womp womp. I was actually surprised that I didn't pass it. I felt good on it. So here we are. Learning some new things, making sure we know how to do everything, obviously. Getting more involved with it, and just gonna have to pass it this next time. Yeah, sucks though. Hey, thanks brother, appreciate it. Next time, that's right, that's what we're focusing on. I get you, Dennis. I get you. Let's just make sure. I always want to make sure I got the right codes going. 2018 for lateral, 2015 for the provisions. Okay, beautiful. Okay, just want to make sure. Oh, Louise, we got our first response in the chat. He's going with wood. The rest of his life, building material, he's got wood on there. I love it. Dennis throwing some shade, though. I mean, think about it, though, Dennis. Wood means you get to use mass timber. Mass timber, they're going pretty tall nowadays. So, got some options there. I'll be right back, team. Raymond, a team member, coming into the chat right now. What's going on, Raymond? All the way from Washington. I say all the way, that's actually kind of close in comparison to Cincinnati today. What's going on, Raymond? Welcome in. What are you working on? And since you're here in person, I'm going to say it. I appreciate your support for the channel. It really does help. So I appreciate you a lot. Welcome in. You get 2 bags of popcorn today, so go get them. Now it is. I turned it off when I'm getting back into it, so I'm not causing any mayhem. Can you hear me all right? I see it moving. Can you all hear me? My God. Thanks, Nicholas. Hey, welcome in. Studying for the PE, cool. Sitting for it in March, nice. So we're in that same kind of study zone. I gotta wait until April 1st to take this first portion of the lateral exam, and then mid-April I could take the afternoon portion of the lateral exam. The channel's been more helpful for the afternoon stuff than the 3K I spent at PPI. Oof. I know it sucks. I've spent a good amount of money. I mean, I'm thankful that School of PE sponsored me one time to actually 2 times, actually, both for gravity and lateral. They gave me an old course that I could flip through. So that was really generous of them, and partnering with them. But besides that, I've been doing my best just to do it on my own with the resources that I have, but even still, you get hit again with the fees to even take the test, which I know is pretty spendy. So we don't all have that cash lying around, and then if you don't pass it the first time, you gotta buck up and pay for it again. So it's a lot. It's a lot of money. It's one of those talking points that the industry talks about, of like a barrier to entry, of pursuing a higher level of engineering certification, whether that's the PE, whether that's the SE, the GE. You can be smart, but you also got to have some bread to spend. I'm glad my channel has helped you, and that you're a team member and you're helping support the channel. Thankfully, you're not spending $3K on the channel. But yeah, all the stuff is going to remain free. Hopefully the ads take care of everything to, keep making the content better and all of that. But I never want to have any of you have to pay through a paywall in order to get to information that you're looking for, just to study or just to learn. I mean, that's the point of why I started it in the first place. So, all right, let's get back into it. We got a little bit more time. No, I'm not looking at the subscribers. I'm looking at our Pomodoro 45 minutes. So let's stay locked in a couple more minutes. What's Copilot? What is Copilot? All right, sorry. Quick tangent. What the heck is Copilot? Oh, like Microsoft Copilot? That's what I'm... Is that what I'm seeing right now? This guy? This like AI companion? What is this? Ask me anything. Is this like their ChatGPT? Look at this. Yeah, that's exactly. Yeah, that's what I'm thinking, Nicholas. Look at it go. Look at it go. I throws in some emojis. Freaking. Let's go. No shit. It's up, and it's throwing shade as well. I mean, I'm gonna take it if an AI software with Microsoft is recommending my video. That's so cool. Complete walkthrough, and then they're just like, by the way, it's kind of long. We could probably like trim it up a little bit if it was us, but we didn't do it. But whatever, that's fine. That's fine. I fucking love that. That's so cool. Good luck, knock them out. But it's worth it, and then they hit me with that chef's kiss smiley face. Yes. Look at that. #1 reference. Come on now. And they got Sky Civ, ICC, University of Memphis. Dude. What? And if you just like complete walkthrough video?
Can somebody say,
oh my God,
rigid diaphragm design? We've been over.
This was a time in my life. This was a time. My goodness. COVID, the long hair. God, I've learned so much more about rigid diaphragms since this time. Cool. Wow, Copilot. All right, you learn something new every day. The future. The future. It's now. Pavin, hey, welcome in. Our fellow SE. How the bridges, they holding up? I know not in the US. What's going on? This is so cool. This just made my day. Awesome. All right, back at it. They're holding up. I like it. Yeah, that's the plan. So I'm gonna take the morning portion, like whatever, April 2nd or 3rd kind of thing, because that's after April 1st is when they're opening up that you can sit for the morning portion, and then you can take it anytime throughout the year. So I'm locked and loaded for that. And then the plan is, I mean, we'll see how that goes. I'm hoping to kind of like, just like, let's focus, get that one out of the way. That one's never really been the problem, but I'm more so going in needing to make sure that I'm prepared for the style that this is going to be in, because it's the first time ever. And you know, I'm a old school kind of guy, pen and paper, but got to figure out how the computer format works. And then, yeah, if all goes good, then we roll right into the afternoon. And I may just roll right into the afternoon anyway for April, whatever, 15th or 16th. So. Shabam, welcome in. Which field are we doing engineering? This is structural engineering. Gonna do any videos? I am not the one to be doing videos on bridge questions, let's be real. I mean, maybe after I'm done with this test, so I can like give myself some backup to say like, yeah, okay, I'm an SE. And then I can do some bridge problems, but I mean, I'm just as much of a noob as anybody else. I'm just faking my way, getting through the SE in terms of AASHTO design. But I could get into it. I could get into some bridge design. Need any thumbnail designer on video editor? I mean, all that free time that I have. Yeah, I mean, I'd be game. Are you good? Connect with me on, go to my YouTube page and go to the contact info and you'll see my business email. Send me an email, let's talk, see what's up. But close, Raymond. You got no idea. Pavan, it's funny you say that because I just rolled the dice on the PE and skipped masonry altogether because I'd never done it. Hey, Pavan, thanks for coming in. Good talk. Later. Enjoy your Sunday. See what's going on, what's going on. Oh, yep, you caught me. Yes, the double top plate. I almost took the full section. No, 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 you can only get one. Good catch there. That took me a hot sec to just pick up on that. What else you got? Most commonly, plate splice is achieved with 10 Ds, 2.5 inches long. Wouldn't you have to take some reduction for the 3.5 inch 16D nails? Let's see. Yes, I mean, if we did 10Ds, then this value would change. So I did 8D to see what the value is, and then I did 16D to see what the value is, and this load slip modulus variable is dependent upon the diameter of your fastener at the splice. So if I did 10D, that would be, let's see. No. 0.148 would be your diameter if it was common. So that would indeed get us a value that's in between these two values. I reference IBC 2304.10.1. Wouldn't you have to take some reduction for the 3.5-inch 16D nail? Huh. I'm not sure I know what you're getting at. That's kind of the most that I'm seeing here. IBC, let's see what's up. Let's just double check. Portion of that nail penetrates the wood, because you're saying it's penetrates a 1/2 inch. Yeah, I'm following you there. Stand by, let me just make sure. So I need to go off of the 2018 IBC. All right, so 28 IBC. And you're saying, I'm guessing the wood, 2304, I'm guessing is chapter 23 is wood. Yep, okay, 2304. Anybody who doesn't know about, where am I? Oh, this is just ICC. Yeah, go here. 2304, 10.1, table 10.1. Okay, so we gotta go down. Table. 10.1, fastener schedule. Oh, okay, this is like all the IBC minimum requirements for nailing. Okay. And what you getting at? You reference this table, 10... for basic, you're saying you reference this table for specifications of cord splice connections. Let's see, can I find it really fast? Top plate to top plate? Top plate to top plate at end joints. Each side of the end joint. Bottom plate to joist. I think it's this one, top plate to top plate. Is what I think they're getting at here. I don't use this table all that much. Usually we just, number 12, okay, nice. So you do 16D, or you can do 10Ds, or you can do this. 16 inch on center, 12 inch on center, because that's, what is this? This spacing? Spacing, number, and type of fasteners. Number and type. Just gives you type. Staples, oh my god. Yeah, so this is all minimum IBC criteria. I mean, you can design it whatever you want, but I mean, from derivation through the NDS, so this guy over here, and more specifically through the special design provisions for wind and seismic, it really, all I'm seeing is it's just dictated by D. If I flip this back over. So like, we need this value, number of fasteners that you've designed for. I get what you're saying because you penetrate, but it's based on nail slip. So I'm thinking that because of that, you're not getting any reduction because your nail fully penetrated your cord. Because you still have, it's based on the diameter, so you still have that diameter running completely through your cord connection. So you don't have to take any loss because your fastener penetrated the full way. I'd almost say the opposite. If your fastener wasn't long enough, do you then, well, and I guess it doesn't really matter. I mean, it matters. That's going to come into effect when you're designing your splice for the shear capacity. But for the deflection portion of the calculation, they're telling me it's just dependent upon the diameter of your fastener and then the number of your fasteners. So I guess that's where I would rationalize to myself to say, as long as you designed your splice to be able to handle a lesser embedment or a greater embedment, then that part's checked off, and then this part is just, okay, what's the diameter of the fastener? Move on, let's keep going. That's my only take, though. And then to back it up as well, I'm going to say that in the commentary of the special design provisions, they actually have a diaphragm. Actually, they have a bunch of design examples that are really nice. So I double checked with the design example for diaphragm deflection and cord splice calculation and doing this step. So they have the same thing as well. And I don't see anything based on having to check or modify this value based on your fastener choice. CNDS table 12, R footnote 3. Uh-oh. Has it got me here? Let's see. Table 12. Oh, you're going to the NDS, huh? NDS table 12. Which NDS do you have? 2018? All right. Where the nail or spike penetration P is less than 10D, but not less than 6D. Tabulated lateral design value Z shall be multiplied by P over 10D, where lateral design values shall be calculated using provisions of 12.3 for the reduced penetration. So there you go. So that is for your shear value. So that's for the connection itself. 12.3, let's see. And then here's all your yield modes for your single and double shear. Yes, so this, I would agree with you. I would say when you were designing your splice for shear, you need to take that into consideration, that footnote based on what type of nail, how much penetration you have. But as far as I can see, once you do that and you satisfy that, then when you're calculating your deflection, that process is already done, and the only variables that I am seeing for the deflection calculation is just dependent upon the diameter of your fastener itself and the number of them at the to determine the slip at your splice. So that's just my take, though. But great call out, for sure. Because I guess I would say it like this. If you, let's keep it up here. If you have a splice in your cord, And your nails only do that. So your penetration P is very small. And it's the same on the other side. When you are checking or designing the capacity of this splice, your Z for each nail is going to be really small because it's only got a little bit of penetration, so you get hammered really badly. So subsequently, in order to make that connection work, you would need to specify a greater number of nails in order to make that work. Then, when you're checking diaphragm deflection, both of those variables are taken into consideration. So when you are getting this variable here, it has both the number of fasteners and the load slip modulus, which is, we said, is dependent upon just the diameter of your fastener. So you've already calculated that, man, you need a lot more fasteners at the splice just from a strength level for shear capacity. Well, that's taken into consideration, even though your penetration is small, which means, that connection would slip more than a connection that has deeper fastener penetration. But if you had deeper fastener penetration, you wouldn't need as many nails. So in essence, you can say, well, I need 4 nails with a penetration that's high, or I need 8 nails with a penetration that's small. And both of those values turn out to be the same thing when you plug it in for the calculation for deflection of the diaphragm. Hopefully, that's how I'm convincing myself anyway. Okay. Yes, I love that. I love the agreement. I love the call out though. That was excellent, because you're totally right. I mean, wood gets really finicky. I mean, all the materials do, but wood comes down to really connections. Wood's pretty straightforward with the actual material itself to a degree. I get it. There's a bunch of different species. But the connections are really the finicky thing that's like, you got to go so in depth to figure some things out. All right. All right, gang, we're gonna go for just a little bit longer. I'm gonna get up, stretch my feet real fast. Make sure you do the same, and then we'll do, we'll do like another 20, 25 minutes. All right, see you in a second. if you could hear me. Jappy, thanks for subscribing. Welcome to the team. Come on in. Get your popcorn in the back of the auditorium. Pick out your chair. Anyone that you see, just if it has a little reserve sign on it, means, there's already a team member that's there. But we expanded, so you got a bunch of seats to choose from. If you want to come up front, come up front. If you want to go way in the back, yeah, there's some room back there, but Jose's back there, so just, watch what you're getting into back there. But hey, thanks for subscribing. Ooh. Almost there. Pretty fun. Nice team. All right, I think I'm gonna end it there. What is up with Jose? Man, what is up with Jose? Raymond, that's the question that we're all trying to figure out. Maybe one day he's gonna graduate, move on, get out of here. But for right now, I think he already has graduated, but he's just too obsessed with structural engineering. So he hangs around. I think we're at a great spot to wrap up. I just finished diaphragms. So we did, little out of plane, very briefly at the beginning there, pretty straightforward. And then we kind of just churned through some diaphragms, deflection and strength. Yeah, I got a little bit more involved with deflection than I had in the past, so that was good. And I'm feeling good. We're feeling good. And now I'm staring at shear walls, so next time, I might be doing it solo, but I might be back here. I'll be knocking shear walls out. The only thing technically with diaphragms that I haven't, that blends with it is the sub-diaphragm analysis. So technically not done with diaphragms, but done with basic diaphragms. I'm gonna keep that sub-diaphragm something separate, its own little task. And shear walls, we'll knock out the different types of shear walls. And then, that includes the type of shear wall, the strength of the shear wall, and then the displacement of the shear wall. So those couple things, just like a diaphragm, the only thing that's missing is that you actually have a couple of different parameters that you can do for your type of shear wall. So that'll be good. But we'll brush up on that quickly, and then we're out of wood. Wood was never the issue. Although I said that for, the gravity exam. The first time I took the gravity exam, and of course, that was the thing that stopped me. I can't believe it. It's the question they asked in the afternoon was the one thing I didn't study, and I fudged it up. Super unfortunate. It passed, my diagnostics passed everything else. Oh, it was heartbreaking. So I never want to just think something is okay, good enough. Let's make sure that we know it. But yeah, I feel good about wood. This is just a quick little pick-me-up. And then let's get back into concrete and steel, the two that I want to make sure that I'm really wrapping my head around. What are some of the questions you remember from the SC lateral? Unfortunately, I can't tell you. That's part of the rules, is that you are not, I don't even know if you're what happens, but let's not go down that path. But you're not supposed to talk about questions, what was on it, stuff like that, because they try to recycle and, not have to come up with a billion different types of questions for this exam. They take a lot of time to curate a question so that it touches on, every aspect of what it means to be a well-rounded engineer. So once they have one of those, I feel like they don't want to just poof, it's gone, everyone talks about it, and then they have to do the same thing next year, the same thing, and then eventually they are making questions that are just so arbitrary because they've run out of material. So long story short, I cannot tell you. But we do a lot on this channel that cover, or I should say that prepare you for types of questions that they cover. So come check out videos that are coming out, videos that have come out on some great topics. Thoughts on the new PE civil structural format after April? Oh, it's freaking wild. I can't believe it. I want to say that's a huge, a huge boost for civil structural engineers. I think that's the absolute right way to go. Most people that I've ever talked to, including myself, the majority of my studying for the PE was studying the morning breath stuff of everything else that had nothing to do with structural engineering. So I think that's a big plus. And I'm excited for individuals moving forward that are going to be taking it. Yeah, I agree with you, Raymond. I'm curious to see or hear people's opinions about how it went, because the way that I kind of understand it, it's sort of like a mini SE. I mean, it's like a gravity and lateral sort of kind of exam, just PE level knowledge. Is that true, or am I totally off here? Nicholas taking it this fall. Let's go. You're gonna be our eyes and ears. Let us know how you felt. Hey, I mean, if you want to, reach out to me on the YouTubes. Hit me up with an email, and if you want to, I'd love to do an interview with you. You could be on the channel, talk about your experiences. Or if you don't want to, that's fine too. I get it. Looks like a mini SC. Okay. I think that's also better to gear PEs after they get that done, moving into preparing for the SE, kind of already being conditioned to the formatting of like, all right, I get the direction that I'm going. I just need to enhance my skills a little bit more in order to take that exam. But yeah, I'm just gonna chill in here just a couple more minutes. I'm gonna kind of peruse. This is lateral depth. What do they show here? Wind and earthquake, 5.5 hours, totaling 60 questions. Because it's 5 problems, 12 questions each. There we go. And a scheduled break. A scheduled break? I saw that for the morning breath. Where was it? I saw a scheduled break as well. And I'm like, what kind of scheduled break are we talking about here? The old format was 4 hours, 4 hours. You get a break for lunch in the middle. Like, I don't want to take a break in the middle of my 5.5 hour session. It's not that bad. Let's just like get going. Like once you're in, you're locked. That's gonna be a little silly. I wonder if you could waive that. Computer-based. It's closed book with electronic references. It's included with the exam along with the design standards shown on the last page. Okay. Buildings or bridges. All questions are alternative item type. What the hell is that?
Examinees taking a computer-based NCEES exam may see up to 5 types of questions on their exam. The question types include traditional multiple choice questions that feature 4 answer options from which to choose, one of which is the correct answer. Multiple choice questions with multiple correct options feature more than 4 answer options from which to choose and allow for multiple answer options to be selected. Point-and-click questions require you to select one or more predetermined clickable areas that become visible when you move your cursor over the graphic. Drag and drop questions require you to click and drag your answer options to sort, rank, match, or label a provided graphic. Fill-in-the-blank questions require you to enter your response instead of choosing it from a list of answer options.
So I guess that is what's going down. No more breath exam. Civil Engineering Academy. Get it. Get up out of here right now. He's actually got some great information if you ever are curious. He goes much more into depth about the information on the exam. Is it like that for the lateral breath? Oh, wait a minute. Examinees have 6 hours to complete this exam. 55 questions. Scored and unscored. 6 hour time includes tutorial, scheduled break. Okay, because you got a break in there again. Silliness. The exam section uses the US commentary system. Where's the... Oh, 55 multiple choice questions. I didn't see them specifically say, like they do here, the alternative item type questions. So, looks like the afternoon gives you more variety. Still kind of weird because I'm used to the, essay style questions, but I guess in the grand scheme of things, the essay style questions, it really did just kind of break down to like asking you like 5 or 6 things, but it was open response. Frank, I'm taking the morning portion now that they split it up into 2. Early April, when you're allowed to. April 1st and onward is when I'm allowed to sit for it, so I'm gonna do that then. I thought I could take it any time in 2024, but it starts April 1st, so I was gonna take it like beginning of March, but I just get an extra month to study, so that's fine. And then I want to just roll right into sitting for the afternoon portion of the exam in mid-April. So that's the plan. We just keep on keeping on. All right, so where were we? Choose buildings or bridges, computer-based, okay. Okay, that's all the same. 5.5 hours. At least one scenario for each of the following types. At least one scenario. Steel, concrete, wood or masonry. General analysis. That's the same, okay? At least 2 scenarios include seismic content at seismic design category D and above. Oh, I didn't even read that last time. I mean, it doesn't matter for me because I'm always in seismic category D or above. The funny thing is it's actually having to study down to do a less strict design methodology when you're below this. So that's the interesting thing. Okay, wind, high wind scenario may include multi-story buildings. Yep. May include foundation, okay. Okay. Category A. Category A is, yeah, that looks good. That'll do. She'll do. Oh, bridges. Oh, buildings. Oh, that's it? That's what they tell you? Yeah, right? Yeah, there you go. Yeah. 1% seismic weight, moving on. See you later. Hey, see you later. I flagged that in an early video that I made on my channel where it was like, attention, there are 2 sections in chapter 12 that you need to be careful of. There's the seismic design category A section, which is simplified, which is super straightforward, but super basic. And it looks identical to the actual design provision for anything above seismic design category A. And they're right next to each other. So don't accidentally flip to that page and think you're in the right spot. Just seems wrong. I mean, design category A, basically like, take like Massachusetts, for example. I'm pretty sure that's A. I don't think there's ever been an earthquake in history. So why, I say why even design for it, but it's like, okay, like if it's not happening, or if it does happen, nothing's nothing's gonna shake. So yeah, I mean, designed for absolute minimums. All about playing that probability game. Okay, so I mean, that's all of the potential content is the same. Bridges, okay. That's interesting. Whereas in the breath, they hit you with that, you know, like, okay. Yeah, analysis of structures. Design and detailing is the other half. Wait a minute. 28 to 46. Why did they say 55, but then they only go, am I missing something? Oh, 28 to 46, 17 to 26. Oh, yeah. I get it. I get what's up. Okay. Low distribution. Height limits finishing. To be quite frank, I had as good a time as you can have taking one of these exams in the morning. I thought the questions were great, like, you know, questions to get the juices flowing and move through and make sure that you get the overall concept of the gotchas within, you know, what is allowed for lateral design of structures on a conceptual level. It's like not like you're doing these nitty-gritty calculations on everything. It's more high level, like schematic level design of like, hey, if we did a building this big, like what do we need to watch out for? What are the pitfalls? Which is much more like, I mean, really good, what do you want to call it, skill to have as an engineer. Not needing to do the calculations all the way to the end to say, oh crap, I have a problem, but to be able to identify them early on was a lot of this stuff. And I didn't feel like I had the most difficult time. It was still difficult, but I moved through the problems. So I'm gonna focus a little bit more on wind. I wanna lock that in one more time. I think I went a little fast on wind in my early studying. Seismic I'll do a little bit more in a couple of areas, but I'm gonna make sure I know steel and concrete a little bit better. Although concrete, I'm not that far off the concrete. It started to click pretty dang good last time. Steel's still a little bit of a mystery for me.
I don't think that
But
I can figure out where my mind is trying to go. No.
Where is this music going? Where are we?
No, I can't figure out if
But again, I get the overall concept of steel lateral design and the systems that we've used, ductility, you know, like capacity-based design of your lateral braces, stuff like that. Your moment frames, whether it's concrete or it's steel, it's the same type of design procedure. Your probable moment, you know, the design of the structure most likely is going to be driven by your drift limits rather than strength requirements and all that stuff in between. I really started to digest last time, so I'm excited to get back to those things and then just get even more info on them and then lock them in and be an SC. You know, that's like, why am I might as well say it. Eventually it's gonna happen. So we're gonna get there and then we're gonna be a damn good one. You best believe, just like everybody in here in this chat. All right. I think we're gonna call it there. Hey, appreciate everybody's time today. Yes sir, Frank, yes sir. Your hard work, even if you just stopping in to say hi. I know you're working in the shadows, in the background. And, you know, thanks for engaging with all my content. Thanks for subscribing. Thanks for liking. It helps push out this content to other engineers who are unaware of it. So keep correcting me. Keep picking through my work, finding the nitty gritty, asking the difficult questions that no one seems to want to answer, and I'll get into it. I promise. All that being said, if you haven't subscribed and you do want to, hey, subscribe down below. It's like over there. Oh, no, it's like over there, I think. And catch you all next time. Little baby boo. All right. Later, everybody. Appreciate you. Peace.